Okay, so let me take a detour from the photosynthesis tutorial back to the respiration tutorial, because there's this one question that we skipped, right? If you remember lah. Okay, so anyway, the question talks about the differences, right, between the flow of electrons in photophosphorylation versus that shown in figure 2.1, which is oxidative phosphorylation. Okay, so we have done the differences, right, between photophosphorylation and oxidative phosphorylation. However, obviously not all the differences are relevant here, because the question is has a boundary, right? The boundary is number one, it must be shown in figure 2.1, right? And number two, it is only on the differences in the flow of electrons, right? So we are not looking at H plus, right? Just flow of electrons. Okay, so with that, okay, here comes the answer. Right, so we can look at the source of electrons, right, which is part of the flow, right, where the electrons come from. So this one difference is possible. Another difference we can look at, of course, is the direction of flow of the electrons, as well as the end, right, end of the flow, the final electron acceptor. So these are some of the relevant differences that we can look at. Okay, so for the source, I think we have kind of explained, right, just now in the differences, right, between the two types of phosphorylation, so I don't have to talk too much, right? Just take note, because the boundary of the question requires what is shown in figure 2.1. So instead of reduce FAD, which is not shown, right, we can only write reduce NAD here. Okay. As for photophosphorylation, I know the source in the table of differences is water, right? But here I write chlorophyll A molecules, because if you compare it to figure 2.1, we are looking at the one thing that directly donates the electrons to the ETC, right? So figure 2.1 is reduced NAD, right, that directly donate the electrons to the ETC. So the more relevant or the more parallel comparison would be the chlorophyll A molecules instead of water, right? Because it's the chlorophyll A molecules that pass the electrons directly to the ETC, right? Okay, and then the water, once it is split up via photolysis, the electrons go to the chlorophyll A molecules to be excited again, which then get passed directly by the chlorophyll A molecules to the ETC. Right, so the answer here is different, right, from our table of differences just now. Yeah, okay. So understand why, right? Or when the question, the boundary or the requirement is different, we write different things, even though it's kind of the same concept. As for the flow of electrons, right, the direction, we have cyclic versus non-cyclic, right, for photophosphorylation. But for oxidative phosphorylation, there's no cyclic or non-cyclic, it's just a linear flow, so kind of like non-cyclic. And because it's from figure 2.1, so it clearly shows us the different ETC complexes, which are the electron carriers, right? So we can actually name the ETC complexes, right? 1, 2, 3. Okay. As for the final electron acceptor, that would be quite simple, right? That would be NADP versus oxygen. Okay.